Hello, today we're going to be talking about lesson 7.4, properties of special parallelograms. Take a second to check out the do now at the top here. Determine whether each parallelogram can be proven to be a parallelogram and justify your answer. Remember, that means pick out some of those theorems that we would use to justify. So pause the video, try it out. All right, for A here, yes, this is a parallelogram. You have opposite angles are congruent, 48 and 48, and we can figure out this one if we want to, but we don't need to. For B here, we have no, it is not a parallelogram. We need to have that the same side is congruent and parallel. Right now we have one set of opposite sides is parallel and one set of opposite sides is congruent. So there's no theorem that makes this a parallelogram because we need same side parallel and congruent. So, special properties of parallelograms. All parallelograms we know have these things. Good reminder for ourselves. We know that they have opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And then diagonals bisect each other. That's something that every parallelogram has in common. Let's look at some of the special parallelograms that we were starting to learn about the other day. So a rectangle, for example. Rectangles have the same properties of parallelograms and all angles are congruent. Another way of saying that is that all angles are right angles. And then the diagonals are also congruent. So every angle is a right angle. And this diagonal is congruent to this diagonal. All right, a rhombus. Rhombi have the same properties of parallelograms, plus all four sides are congruent. All four sides are congruent. Diagonals are perpendicular to each other. All right, diagonals are perpendicular, so there's a right angle here. And then diagonals bisect opposite angles. So that means that this and this angle are bisected. This and this angle are bisected. So we can use the alternate interior angle theorem to prove that this angle is congruent to this angle because we know that these lines are congruent and this is a transversal. So this angle is bisected, so these two are congruent, and this angle is bisected. So those two are congruent as well. All right, squares. Squares are both a rhombus and a rectangle. So they have all the properties of rectangles and all the properties of rhombi. So let's set up a chart. I'm going to flip the page over here because I think a chart can be really handy. It's a good visual of how we use these properties. So parallelogram has two pairs of parallel sides, has two pairs of opposite congruent sides, has two pairs of opposite congruent angles, has supplementary consecutive angles, and has diagonals that bisect each other. A rectangle has four right or congruent angles, and the diagonals are congruent. Rhombus has four congruent sides, The diagonals are perpendicular. And the diagonals bisect opposite angles. Squares have all the properties of parallelograms, all the properties of rectangles, and all the properties of rhombi. So let's do some examples. I'll give you a second to write down that square because I wasn't recording it. Sorry, guys. All right, our first example here. A quadrilateral has diagonals that are perpendicular. We need to select all figures that's true. Perpendicular diagonals. Well, the perpendicular diagonals for a rhombus, but remember, squares also have the property of rhombi. So it's both of those. Quadrilateral that has 4 congruent angles. We know that rectangles have 4 congruent angles, and squares have all the properties of rectangles, so squares as well. Quadrilateral that has 4 congruent sides and 4 right angles. 4 congruent sides. Rhombi have 4 congruent sides, and so do squares. Sorry, I didn't need to check that. But we also need 4 congruent right angles. Rectangles have 4 right angles. So the only one that has both 4 congruent sides and 4 right angles is squares. And the last one, quadrilateral that has opposite sides are parallel. That's all of them because they're all parallelograms. All right, let's take a look at some more examples. I'm going to switch the page here. For this one, we are selecting only one figure that gives you the property that is always true. All right, just one figure that is always true. So take a second, pause the video, try out these first 6. All right, quadrilateral is equiangular. That means they have congruent angles. That would be rectangles. Quadrilateral that has diagonals that bisect each other. All parallelograms have diagonals that bisect each other. Quadrilateral that has diagonals that bisect opposite angles. That would be rhombi. Rhombi. Quadrilateral is equilateral. So equal sides, that's also rhombi. Quadrilateral that has congruent and perpendicular diagonals. Congruent and perpendicular. We know that rectangles have congruent, rhombi have perpendicular, so this is squares. That's the only one that has both. We know quadrilateral that is regular. Regular means that it has congruent angles and congruent sides. Remember that from the other day? Congruent angles, congruent sides. That is only squares. All right, try the next 6, 11 through 16. Pause the video, try the next 6. Our first picture here shows that we have 4 congruent sides. That is a rhombi. You do not know the angles, therefore you cannot say it's a square, even if it looks like it's 90. Yes, and I look like I'm, 25. I'm so not. For our next one here, we have parallel sides. Opposite sides are parallel. That's parallelograms. We cannot get any more specific than that. For number 13, we have the opposite angles are bisected. So this is a rhombi. For number 14, we have that the diagonals bisect each other. That's a parallelogram. For number 15, we have that the diagonals form a perpendicular, right? There's a 90 degree there. That is a rhombi again. And then we have a right angle here. If this is a right angle, we know this is, and therefore all of these are right angles. This is a rectangle. All right, let's check out the very last page. For these ones, we are having to solve. So I'm going to do one of these with you, and I want you to practice the rest. All right, so we're going to check out number 17. We've got PQRS is a triangle. And actually, maybe we'll do 3 of them together because there's lots of different ones. So we know that PS is 10. We're looking for QR. QR would also have to be 10 because we know opposite sides are congruent. PQ is 24. SR would also have to be 24. Next, we need SQ, which is this guy right here. Well, SQ is a part of this triangle, if you can see it, right? And we know that this is a right angle because it's a rectangle. So that means we can use a squared plus b squared equals c squared, where SQ is our c squared. So we have 10 squared plus 24 squared equals SQ squared. So when we do that, we end up with 26 equals SQ. If you want to go back and review how to do Pythagorean theorem, that was in chapter 9, but I assume you guys know how to do this. Because you get 100 plus 576, so that gets you 676. Square root of that is 26. So this is 26. Next one we have is PR. That's our other diagonal here. Well, we know the diagonals are congruent, so this one is also 26. It's a special property of rectangles. The diagonals are congruent. So SQ is congruent to PR. For PT, that is, T is going to be the midpoint because the diagonals bisect each other for any parallelogram. So we would need to figure out what half of 26 is. Well, that should be 13. And then we also have an ST that is also 13 because SQ is 26 and we know the diagonals bisect each other. So this is going to be half of it. All right, let's try 18 now. We know that ABCD is a rectangle, so we are looking for angle 1. Well, we know that angle 1 plus 27 equals 90. So angle 1 should be 63 degrees. Because this side and this side are parallel, opposite sides are parallel, we have a transversal here. That means angle 1 is congruent to angle 2 by the alternate interior angles theorem. So this is also 63 degrees. Angle 3 is right here. Again, we can use the alternate interior angles theorem, 27 and 3, because this base and the top JK here are parallel, so we know 3 is going to be 27. The other thing you could do is you could add angle 2 and angle 3 to make 90. You already know angle 2, and therefore you can find out angle 3. So there are many ways of doing this, which is nice. All right, the next one, we're looking for angle 4. Angle 4 is right here, and we know that angle 4 would be congruent to this angle down here. Interesting little thing here, we know that these diagonals are congruent to each other, right? You could actually use the isosceles triangle to say that these base angles, the base angles theorem, to say these base angles are congruent. So you know that angle 4 is going to also be 27 degrees. Again, there are many ways to get to find out what angle 4 is. Right? There are many ways to find out what angle 4 is. That's just the way I chose. Angle 5 is right here. Now this is a rectangle. Angle 5 is not 90 degrees. That's only for rhombi. So when we're looking for angle 5, we actually have a triangle right here. We know that we have 27 plus angle 4, which we just found, plus angle 5, and it's going to equal 180. Well, angle 4 we just said was 27, so we know that angle 5 has to be 126 degrees. And then we're looking for angle 6. Well, angle 5 plus angle 6 is 180 degrees, because they're a linear pair. So that means that angle 6 is 54. The other thing you could do with this one, if you wanted to for angle 6, is you could use the exterior angle for a triangle theorem. We add our two non-adjacent interior angles, which would be angle 4 and angle 27. That would equal angle 6. Both those work. All right, let's check out 19. First side that we are looking for is JM. They have told us that JK is 12 and that JN is 7. This is a rhombus. That means that all of these sides are congruent to each other. So JM must also be 12. The next one we're looking for is JL. Diagonals bisect each other. So that means JN is congruent to NL. So that whole thing would be 14 then. The next one we are looking for is MN. We're looking for MN, which is this guy right here. These diagonals are not congruent. All right, they are not congruent. Let me make sure I say that 7 or 8 times. So we know that they are perpendicular, however, and we have 7, some unknown, and our 12. So that means we have a squared plus b squared is equal to 12 squared. Oh, c squared. Sorry, which would be our 12 squared. So we have a 7 squared plus a b squared, which is our j, or mn, which is the same as nk. So when we do this, we end up with our b is equal to the square root of 95. So that means that mn is also equal to the square root of 95. And then we want to find out what mk is. Mk, so that's this whole distance here. Well, it would be twice mn because they are bisected. All right, let's take a look at number 20. The figure is a rhombus. We're starting with angle 1. Rhombi have diagonals that are perpendicular, so we know angle 1 is 90 degrees right off the bat. We can mark it. We can be certain of it. The next one we want is angle 2. Well, we know that angle 1 plus angle 2 plus 38 is going to equal a triangle right here. So we know that angle 2 must be 52 degrees. Our next one, we're looking for angle 3. Angle 3. Remember, rhombi have diagonals that bisect their angles. That means angle 2 and angle 3 are congruent to each other. So angle 3 is 52 degrees as well. Angle 4 is up here. Angle 4 is going to be congruent to this side, which we don't know, unfortunately. But we know opposite angles are congruent. So we know that angle 4, because this is parallel to this, and this is a transversal, we can use the alternate interior angles theorem to say angle 4 is congruent to 38. So angle 4 is 38 degrees. Now in that chapter 3, parallel lines, it just never goes away. It's great, isn't it? Let's check out angle 5 next. Angle 5 is right here. Again, we know that this angle is bisected. We can use the alternate interior angles theorem to say that angle 5 is congruent to angle 2, and angle 2 we found is 52, so angle 5 is also 52. And then our last angle is angle 6. Our last angle is angle 6. Because this diagonal bisects this angle, angle 6 is congruent to 38. All right, let's check out the last 3. Let's check out the last, 4, the last 4. We know ABCD is a square. They tell us that AB is 10. For a square, it means all of these sides are congruent. So AD, which is this guy right here, is also going to be 10. The next thing we're looking for is AC. That's this diagonal here. Remember, this whole angle in the corner here is a right angle. So we have a squared plus b squared equals c squared. Or if you think back to when we were doing special triangles, you have a triangle that has 2 congruent sides with a right angle. So this is a special 45-45-90 angle, an isosceles right triangle. So you automatically know that your diagonal here is going to be 10 root 2. Either way will work. I like taking the shortcut. So we are looking for AE. Well, diagonals bisect each other. So if AC is 10 root 2, that means AE is half of that. So this would be 5 root 2. For some of these online, you might have to round, so be careful when you're looking at big ideas. Make sure you can see if you need to have the roots or if they say to round it. Angle 1 here, because squares have all the properties of rhombi and rectangles, angle 1, you know, is perpendicular. It's a right angle. Angle 2. Again, all the properties of rhombi and rectangles. That means this angle is a rectangle, but it is bisected by the diagonal. Well, half of 90, because it's bisected, is 45. Same thing with angle 3 here. This is another 45. GHIJ is a rectangle we want to solve for x. It's a rectangle we want to solve for x. So we know 3x plus 2 plus 12x minus 17 is going to equal 90. It's going to equal 90. Another way of saying that would be that angle GJH plus angle HJI is equal to angle J. That's another way of saying it. That's our setup, right? So we have 15x minus 15 equals 90. We get 15x equals 105. Another way of saying that is x equals 7. All right, for 23, FGHI is a square. We want to solve for x. It's a square. We want to solve for x. Well, we know that each of these has 90 degrees. And we also know, because it's a rhombus, that these angles have to be congruent. So angle FGI is congruent to angle HGI. And we also know, because it's a rhombus, that these sides are bisected. Well, if this whole angle is 90 and it's cut in half, that means that we know this angle is 45 degrees. So we can set our 7x plus 3 equal to 45. So we have 7x is equal to 42, which means x is equal to 6. All right, last one. CDEF is a rhombus. Solve for x. It's a rhombus. Solve for x. Because rhombus have perpendicular diagonals, and the diagonals bisect their angles. So that means that we have angle CFG is congruent to angle GFE. So we have 5x plus 1 is equal to 8x minus 20. So I have 3x on this side. When I subtract my 5x, I add 20, I get 21. That means x is equal to 7. I didn't need to plug any of those back in, right? It just said solve for x. So that's all I did, was solve for x. The skills practice will be posted, right? Take some time to work on it. Email me if you have any questions. Please, please, please email me if you have any questions.